So now that we've had a chance to talk about the common fork join pool, and I motivated a little bit about how it works and how you can dictate the size of the common fork join pool and so on, what we're going to do now is we're going to talk about the ManagedBlocker interface in a bit more detail. And this is important because you'll need to understand how to use this in the upcoming programming assignment. So we'll talk about how ManagedBlocker, let me start over again. That was messed up. So now that we've had a chance to talk about the common fork join pool, let's turn our attention to how to use the ManagedBlocker interface, which is the mechanism that's used to allow the pool to automatically expand and contract based on demand. And we're going to talk here specifically about how the ManagedBlocker interface can be used to help avoid starvation and improve performance by allowing more threads to be allocated in order to be able to keep the processor cores as utilized as we possibly can. Now, historically, the Java fork join framework was largely designed for tasks that run to completion without blocking. In fact, if you take a look at the documentation for the fork join pool, it actually says something along those lines, which gives some people the impression that the fork join pool cannot be used for blocking tasks. That is, in fact, not correct. It's just that you have to know how to tune it properly in order to make it work effectively for blocking tasks. And that's what this video will help you to understand. Remember, run to completion really means you just start running and you keep running until you're done and you don't have to worry about blocking for IO or synchronizers or anything else. So what we can do here is we can use this ManagedBlocker interface to handle cases where additional worker threads are needed in order to ensure liveness, in order to be able to ensure responsiveness, in order to be able to improve scalability and so on when operations block. We don't want things to flatline and have performance go down the tubes whenever blocking occurs. And the way this works, of course, as we've outlined earlier, but now we'll go into in more detail, is the ManagedBlocker works in conjunction with the underlying common fork join pool implementation to automatically and temporarily increase the size of the common fork join pool. So recall that the way this works is that the common fork join pool can be used to reclaim threads during periods of non-use and then reinstate them later on very efficiently. And what it's doing is it basically works kind of like a control system where it tries to create and or activate or reactivate threads to ensure that a certain target level of parallelism is met. And as we saw before, for the common fork join pool, that's going to be one less than the number of cores that the system is aware of. In order to do this, the ManagedBlocker interface defines two methods. It's a very, very simple interface. And one method is called isReleasable, and this returns true if blocking is unnecessary because the resource that you're potentially going to block for has already been obtained, and we'll see how that works in just a second. So for example, if we were able to acquire a lock or acquire a message or so on without actually having to block, then isReleasable would return true, saying no need to worry about adding another thread. If it returns false, though, then we may have to have the underlying common fork join pool add more threads. And then the second method, which is really the one that kind of does the work, is called block. And this potentially blocks the calling thread. For example, to wait for an IO operation to complete, like downloading an image from a server or writing a large file to disk or waiting on a lock or whatnot. Block will return true if there's no additional blocking necessary. In other words, if isReleasable would return true, block can also return true. So let's go ahead and take a look and see how the Java common fork join pool actually applies ManagedBlocker in practice. And here's kind of what the code looks like. I'm not going to show every piece of the code and talk through all the parts of the fork join implementation. It's very complicated, but here is the essence of it. So you can see here that the fork join pool class extends the abstract executor service. And you can actually see all the source code if you look at the link at the bottom of the slide. And you can see here that there's a ManagedBlock method, and this method will take a ManagedBlocker, as we'll see in a moment, and it's also a static method. So that means that you don't have to have an instance of fork join pool in order to call it. In fact, this doesn't work on instances. It only works on the common fork join pool, which itself is accessible through the static common pool accessor method. And this method activates a spare thread to ensure that there's sufficient parallelism while the calling thread is blocked. For example, again, downloading an image or writing a big file to disk or whatnot. And the way it works, you can see that within this while loop, it's checking the ManagedBlocker parameter to see if it's releasable or not. And if it's not releasable, it makes a call to a method that's known as try compensate. And what try compensate does is if there aren't enough live threads, it'll create or reactivate a spare thread to compensate for the fact that we're about to block until we unblock, at which point that thread is now a candidate for termination if it's not used in short order. So what we do here is we go ahead and first attempt to acquire the resource without blocking, which is always a good thing because then we don't have to worry about creating these extra threads. But if we can't do that, then we're going to go ahead and call the blocker.block method, which could very well block the calling thread. And we'll see some examples of where it does that when we look at the programming scenarios here shortly. So that's the end of a quick overview of the ManagedBlocker interface. The main thing to remember from this particular discussion is it's only got two methods, is releasable and block. So it's a very, very simple interface. And it's used in conjunction with the ManagedBlock static method on fork join pool, which will try to compensate for blocking by spawning additional threads or a thread to wait until, or to be used until the blocking thread is done, at which point then that thread can be terminated if it's not used for a while.